We're going to talk about combustion of fossil fuels and energy release and how we produce electricity from fossil fuels, and also compare different types of fuels, biofuels, gasoline and wood, and talk about sustainability of biofuels. Okay, I'm going to start with question number 1. You read the question, what are the characteristics of fuel, and describe how they make fuel useful. They must increase a lot of heat energy when it's burned. They must release a lot of heat energy. That's true. Must be able to use and convenient to store. That's true also. Must be reasonably cheap and readily available. That's also true. Must not produce smoke, unpleasant gas, and toxic gases. So everything applies. Answer is easy. These are easy questions. We're going to talk about energy, different forms of energy in next few questions. Various forms of energy. When energy is transferred in a system, the total amount of energy before the transfer is blank after the transformation is complete. The same as, this is law of conservation of energy. First law of thermodynamics. Answer is B. Number 3. A closed system. What is a closed system? Closed system is material don't transfer, energy doesn't transfer. Matter and energy can be transferred in and out of. That's not true. Closed system does not interact with its surrounding. That's true. If energy appears to be gain or loss, it has just transferred into a different system. Energy, what is true is energy is neither created nor destroyed. Whatever produced is same as. What is false? I thought it's true statement. What is false is this is not a, energy can be destroyed, created or destroyed. That's false. Energy can be created or destroyed. A closed system is where material, chemicals, and energy is not released to surrounding. What are the indicators that tells you energy has transferred? Object gives off noise, light, heat. That's true. Object speed up and slows down. That's true. Smelling smoke, hearing a crackle. All of the above indicators are. That's a correct answer. The stored energy is called potential energy. It could be gravitational potential energy or chemical potential energy in bond. Stored energy is potential energy. Energy of motion is called kinetic energy. Light energy is called radiant energy. Energy of moving parts is mechanical energy. Heat energy is called thermal energy. Energy from splitting atom is called nuclear energy. It's a potential energy of nucleus bonding between neutron and protons. Chemical energy is bonding between atoms, broken form, releasing energy. It's called chemical energy. Energy stored in a bond of atom is called chemical energy. Movement of electron is called electrical current. Movement of electron is called electrical, we call a current. Vibration through a matter is called sound. Sound is the vibration form of energy that transfers to a matter through sound waves, vibration. Number 15, stored energy and the energy position are potential energy, stored energy and energy of position of bonds. The vibration movement of atoms and molecules is called thermal energy. The vibration and movement of atoms and molecules increases with the temperature. Is thermal energy, heat does it. The scientific rule that states heat energy cannot be created or destroyed is called law of conservation energy. The energy of a position such as rock on a hill called gravitational potential energy due to gravitation. The amount of useful energy that you get from a system is called efficiency. We talk about power plant efficiency. Not all heat is converted to electricity, only 35 or 37%. The movement of electron energy is electrical or current. The energy in petroleum and coal is stored in chemical or potential energy as chemical/potential energy. Fission and fusion are examples of nuclear energy. Fission, we talked about uranium-235. Fusion takes place in the stars. Hydrogen converted to helium. Hydropower reservoir is an example of potential energy due to gravitation. A path through which electricity travels is called circuit. A device that converts energy into spinning motion is called turbine. The steam turns the blades of the turbine and runs the motor to generate electricity. Device with magnets and coils that produce electricity is called generator. A device that produces electricity through the chemical reaction is called battery. Device chemical energy to electrical energy is a battery. We call it galvanic cell sometimes. An object in which the electrons at one end is spin in one direction and the electron in other end is called a magnet. So magnet has spinning electrons in different directions, north and south. What forms of energy has the greatest impact on making radiometer work? Thermal or radiant energy? Answer thermal. Thermal energy is the one that radiometer, that energy of radiation measuring devices. Which type of system does not allow matter energy to in and out and cannot interact with the closed system? I talked about that previously a little bit. Closed system, matter, chemicals or energy cannot come in and out or interact with surroundings. Surrounding is the outside of the closed system. Dissipated energy is energy that transforms into thermal energy and release into the surrounding. Dissipated energy is the wasted energy that release to the surrounding that make chaos, high entropy in the universe. C is the energy release into the thermal energy release into the surrounding. What is true when energy transferred in a system? What is true? Not all energy gets transferred and some energy lost. That's not true. That's not. They convert it to other energy. Energy gets transferred in different amounts, in different forms, but not 100% transfer. That's not true. Energy gets transferred in different amount to different form with 100% transferring. That is, energy is conserved. Only we lost some of that to a different form. Half of the energy transferred is destroyed. That's not true. C is the correct answer. Energy is 100% converted to different forms. Thermal energy can be transferred into moving atoms when moving atoms collide. This is called, what is that called? Moving atoms collide. Conduction, not conduction. Either convention, this is called conduction. Conduction in thermal energy is conducted through the hot atoms colliding with each other. Copper bar is conducting. Conversion is a bulk transfer of the atoms, like flow of current. Conduction is thermal energy. Let's look at it. Conduction is moving atom collide and energy is transferred. The energy stored in the chemical bond of fossil fuel is potential energy. It's the chemical energy in the forms of potential energy. The energy of motion is called kinetic energy. The conclusion that is impossible to completely convert heat into work without making other changes in the universe is concept that entropy is increasing, disorder should increase, dissipated energy. That's B is correct. Another way to stay in that C is not correct. Either thermal or heat energy, all energy. The second law of thermodynamics. Entropy and increasing chaotic nature of the universe is the second law of thermodynamics, entropy increase. Therefore, a lot of problems in the world when you burn fossil fuel, a lot of energy is released, increasing the disorder. The measure of how much energy is dispersed is given process is called entropy. How much energy is dispersed in a given place. The energy that is released without being converted to electricity and other useful forms. So that is called dispersed, is given process is called, is measured disorder in the universe. The law of conservation of energy is energy can be created but not destroyed. The law of conservation of energy states that energy cannot be neither created nor destroyed. That's D. C is not correct. 39. In which example is the entropy of the initial state greater than the entropy of the final state? Greater than means more disorder in the final state. So a building collapses during an earthquake. A building collapses during an earthquake. Entropy of the initial state is greater than the entropy. That is opposite. Before earthquake, entropy is low. After collapse, entropy is high, disorder. So that's not the answer. A lump of sugar dissolved in a cup of water. Lump of sugar dissolves in entropy of the final state. Initial state is greater. Liquid water freezes into ice. That's the correct answer. Liquid water is more entropy, disorder than the ice. Ice is a solid. Solid has more order. So that's the answer for that. Entropy is related to disorder during a process. In which example the entropy of the initial state lower than the entropy of the final state. A pot of water boils to produce water vapor. Final state is higher. That is correct answer. Water vapor has higher disorder than the water itself before boiling. Which of the correct statement of second law of thermodynamics? Entropy of the universe is constantly increasing, and that is a definite answer for second law of thermodynamics. Entropy. Whatever you do, when you live and do normal things, normally disorder increase. Look at your room after you live in it. It's a mess. So it's because energy, there's more tendency to create more disorder. Okay, number 42. Advertising claims sometimes state that adding something mechanical to car engine oil will allow it to recover 100% energy that comes from burning gasoline. You should be skeptical because it violates law of conservation of matter. No device can be converting thermal energy 100%. Statement, energy is the capacity to work. That is true. Energy is capacity to work. Between endothermic and exothermic processes, we're going to compare in these few questions. The energy flow from a warmer body to colder body is called heat. Energy warmer to colder body is heat, is thermal energy, motion of increase. Number 45, property of matter that determines the description of heat flow is temperature. Temperature is the property that determines the direction of where the heat is flowing. The energy needs to initiate a chemical reaction is called activation energy. We're going to talk about that a little later. Activation energy is the energy that is required to initiate a reaction. Any chemical or physical chain that absorbs energy is endothermic. That release is exothermic. B is the answer, endothermic process, absorb. Now we're going to measure energy changes. For burning natural gas, that is methane, produce carbon dioxide and water. So if you look at the diagram on the right, the methane and oxygen has a higher energy. When it goes to carbon dioxide and water, it has a lower energy. Therefore, it's an exothermic reaction. Exothermic reaction as a reaction is negative 802 kilojoules of energy is released. So this is an exothermic example. It's going uphill is endothermic. First law of thermodynamic state, energy is neither created nor destroyed. That's, you should know by now. Answer D. In an exothermic reaction, heat is released as the reaction proceeds. Endothermic reaction, heat is absorbed. The mass is nothing to do with exothermic or endothermic. Chemical reaction accompanied by release of energy is called exothermic. C. Which term correctly describes the reaction in which energy of the product is higher than the energy of the reactant? Energy of the product is higher. In the natural gas, energy of the products were higher, lower. So this had to be opposite of that, endothermic. So it's a product is endothermic. B is endothermic. Correct answer. Which common process on Earth is endothermic? The production of oxygen by photosynthesis, that's endothermic. The bomb combustion of methane is exothermic. Water freezing to form ice, that's exothermic. Water release energy when it become ice. The reaction of wood with oxygen to form carbon dioxide and water and ash is exothermic also. Only answer is photosynthesis. Now you need to calculate the certain amount of energy in food items sometimes. Cheeseburger is 524 dietary kcal. Since 1 kcal is 4.1 corresponded to. So this multiplied by 4.5, you get answer D. 4 times is around 2000. Okay, D is the correct answer. A calorie is exactly 4.184 joules conversion factor. Therefore, 1000 cals is 1000 kilocalories is 1000 times more. A calorie is therefore 4.184 multiplied by 1 calorie. So a calorie is one dietary calories, 1000 kilocalories, therefore multiplied by 100. So answer is D. Chemical reaction requires 31.3139 kilojoules. How many calories does this correspond in? So you divide by 4.184. So it's roughly equal to B. 31, let me do it. 31.39 divided by 4.184 kilocalories. I'm trying to find out the correct number. 4.184 divided by 4.184. It's about 7. B is correct, 7.502. So these, you will find the conversion factor and convert them. All these problems are similar. Number 61, which quantity represents a large amount of stored energy? How many of you know fat has the largest amount of energy? A. Carbohydrate and proteins have the same. 5 grams of pus. Okay. See, 10 grams of fat has the largest energy. 10 grams of carbohydrate is roughly equal to 10 grams of protein. So these are questions about converting calories and grams. So you had to look at the bond energies to know which produce more energy when they formed. Which bond is strongest and shortest bond? The smaller the atom, stronger the bond and shorter the bond. HF is the shortest bond. All hydrogen and other atom is bromine, chlorine, fluorine, iodine. So therefore fluorine is the smallest atom, therefore HS has the shortest bond and the strongest bond. Which bond is weakest, longest? Larger atom, iodine and hydrogen. So there's a certain things that decide the bond energy. Consider the reaction number 65. Propane gas with oxygen going to carbon dioxide and water, release exothermic, negative is exothermic, 531 kilocalories per mole of propane. This bond formed product are stronger than the bonds broken in the reactants. So when you make bonds, they release energy. To break reactant bonds and produce product bonds, to release energy, the bond formed in the reactant should be higher. So therefore the bonds formed in the products are stronger than the bonds broken in the reactant. That's how it makes exothermic. Other way around, endothermic is the opposite of that. Number 66, the heat energy released or absorbed by a chemical reaction is generally determining the difference between energy got. That it is the same thing like previous, energy must be put in to break the bond in reactants, and energy that is released making the bonds in the product difference. That's a B. We done problems like calculating heat of reaction by bond energy. We done two problems. So how you calculate 67? We done this problem, similar problem. So ethylene molecule, ethylene, C2H4, has 4 carbon hydrogen bonds, 1 carbon double bond, and 3 oxygen double bond. So you add them up, these numbers are there. On the top, that's 4 CH4, 413, that's 4 times that, 3 times oxygen added up, that is the bonds broken. So then you have 2 carbon-oxygen bonds, therefore 4 carbon-oxygen bonds. Carbon-oxygen bonds are here, 4 times 4 that. Water has 2 OH bonds, so 2 times, that's total of 4. So when you do that, you get the bonds broken added up to bonds form, we got the answer. So we done a couple of them. Go back to slides if you don't understand how to do it. These exothermic 754. So this is the same thing. Ammonia has 3 NH bonds. Fluorine has 3 FF bonds. That's the reactants. Then you add them up. And nitrogen trifluoride has 3 nitrogen fluorine bonds, 3 times that. HF has 3 HF3. So you can add them all up. Bonds formed is negative. Bonds broken is positive. So subtracted, you can calculate the heat release during this reaction from bond energy. So these problems are similar. Go back to PowerPoint. I did 2 reactions. So follow up the method, okay, we used in there. The bond energies are given, you have to calculate how many bonds are there. Of carbon, hydrogen in 71, there are carbon-hydrogen bonds, 8 of them. Carbon-carbon bonds, 2 of them. So carbon-carbon bond is 356, carbon-hydrogen bond is 416, then you calculate the bonds broken, positive energy. Then you look into the reactants, 3 times carbon. There are 2 carbon-oxygen bonds. Carbon-oxygen bond is 803 times 3, 6. 2 times 3 is 6, 6. Then 4 times 2 is 8 OH bonds. Then you do the calculation and you get the answer. Answer B. Make sure you get the answers, doing it carefully. The breaking chemical bonds requires energy. That's true. An endothermic reaction is one in which energy is negative. That's endothermic is positive and exothermic is negative. Bond dissociation energy are always positive. That's true. Bond breaking is endothermic. True. Bond breaking absorb energy. So we wanted to look at balancing chemical equations of combustion reaction. If you look at the 76, you have to count all the atoms on reactant side and product side. Complete combustion. Incomplete combustion. Incomplete combustion is CO and water. There are 2 equations, B and D are incomplete, B, C, D. Then you check out each and every one. One of them should be, let's check B. There are 3 carbons, 6 carbon, 6 carbon. There are 16 hydrogen. That's true. That's correct. There are 6 oxygen, 8 oxygens on the 6 plus 8 is 14. Okay, 7 times 2 is 14. Therefore, that is the balance equation for combustion. If you check the other 2, they are not. Okay. Combustion is a chemical process in which the fuel combines with oxygen to release energy and form products with oxygen. B is the correct answer, combustion. Heat of combustion of 1 mole of ethane is 1560 kilojoules. What heat of combustion 1 kilojoule per gram? So you have to convert, this is per mole. That means mole is molar mass in grams. Molar mass of C2H6 is 12 plus 12 times 2 is 24 plus 6 is 30. So this is divided by 30. 156 divided by 30 is A. Let me check it. $15.60 divided by 30 is 52. Rounded out. A is the correct answer. That's how you get. So these questions calculate for per mole, then you have to calculate using heat of reactions are normally given per mole. So it's easy. For number 80, negative 137 multiplied by 3.5 is the answer. Negative. Release is negative. So 137 multiplied by 3.5. 137 multiplied by 3.5 is 479. SC rounded off. So you should be doing these problems, calculating different amount of energy per gram and per mole. Okay. Exothermic reaction involve formation of products having lower energy than the reactants. That's true. That is true for burning methane and oxygen. Methane and oxygen has high energy. Carbon dioxide and water has low energy. That is exothermic. The stronger the bond, higher that's true. Dissociation means breaking a bond. Changes in potential energy occur in chemical reaction. Bond breaking, making take care of potential energy, it become release or absorb, exothermic, endothermic. Heat of reaction is negative, means is the bonds broken in the reactants are stronger. Kinetic energy is the energy associated with movement, and the potential energy is associated energy is the inherent in the object due to its position. That's true. Heat absorbed in a reaction called endothermic. So endothermic, exothermic. Now you know what they are. Now we're going to go into fossil fuel. What is a fossil fuel? Wood is a fossil fuel. Uranium is not. Wood is not a fossil fuel. Fossil fuel is dug from the underground deposit. Fossil is buried under the earth. Natural gas is a fossil fuel because we get it from the wood is a existing, it's not fossil. How is heat energy is generated to electricity in a modern power plant? Heat boils water to make steam, which drives a turbine. That is the correct answer. All others are not correct. So efficiency of power plant and these ideas we're going to talk about in 95. Soft lignite, that is a brown coal, is lowest grade since it has undergone least change since burial, going underground. It's most likely to do that of wood because it's the beginning of the coal. Wood is the one that similar to the what when under earth. Lignite is close to wood. What is an advantage using coal or petroleum as a source of energy in the United States? Coal reserves in the United States are far greater than the petroleum reserve. That is the only advantage. But having it, we force us to burn it, create more greenhouse gases. Okay, let's look at the diagram. major energy source in the United States during the years 1990 to 1950. Petroleum, coal, natural gas, we go know this. Major between 1950 and 1900 and 1950 is coal. That's, you look at the diagram, in that range, major is coal. Different times, different. In the year, equally, our total energy image, various sources contributed. What is the question? In the year 2000. Okay. Coal, natural gas, petroleum is the top one, nuclear energy. Coal and natural gas was the topmost. Petroleum and natural gas. Petroleum and coal and, what is the question? In which of the two energy contributes almost equally to our total? That's equally is here. That's coal and natural gas right here. That is how you answer. You have to get the question. Which is not a known advantage in natural gas over the other fossil fuel? Not an advantage, known advantage. It's not far more abundant than other fossil fuel. That's not an advantage. This is, natural gas is limited. Okay, that's C. About natural gas vehicles. Natural gas emits higher levels of harmful byproducts into the air than the other fossil. That's false. Natural gas has less pollutant. Natural gas is made up of almost entirely what chemical compound? Methane, B. Natural gas is used as a car fuel, in vehicle fuel, in what two forms? Compressed natural gas and liquefied natural gas. That is the answer. Compressed. Natural gas under extreme pressure yield compressed gas. Compressed natural gas, true. Natural gas under very low temperature, LGN, liquefied. That's the two forms. Ethanol in vehicles. Ethanol has positive energy balance, meaning that it produces less energy during the combustion than it produce the fuel. No, more energy is used to produce ethanol. Considering we had to grow corn and use land and irrigation. Ethanol has a positive energy balance. Okay. Then it's what are the common ethanol blends in the United States? 10% and 85%. That is the blends, common blends. Which of the following statement is true? Ethanol comes from renewable energy, is low octane. It is low octane. Is high octane, not low octane. We use ethanol as a anti-knocking agent. So that's D is the correct answer. Ethanol is most basic form, synonymous with grain alcohol. That's true. Percentage of gasoline sold in US has 10% in it. Percentage of sold in has up to 10% ethanol in it. I'm not sure about that question. Biodiesel vehicles. Biodiesel refers to the fact that fuel is coming from organic material. This star also is the correct answer. Biodiesel can be made from the following: new vegetable, used vegetable, soybean, animal fat, all of the above. Fat could be converted to biodiesel by the reaction of methanol. Biodiesel can be used in most engines built since 1994. True. Biodiesel is used as a blend with conventional diesel. What is the most common? Most common is 20%, 80. Propane vehicle. Propane vehicle byproducts with two activities. Propane. Crude oil refining. It's mainly crude oil refining. Propane is number 117. Propane is typically used for fuel in injection in liquid form. True. Propane must be handled with care. Its boiling point is low. It has to be in a tank, otherwise volatile. Hydrogen vehicles. Hydrogen occurs naturally as a gas. True. Hydrogen is odorless, colorless, burns with a blue flame. Currently, most hydrogen vehicles use fuel cells. Fuel cells is an electrochemical cell that is designed to burn hydrogen and oxygen electrochemically, so therefore produce efficient generation of electricity. Their hydrogen is used in vehicles is mainly in the fuel cells. It's a renewable energy source. All of the above can be manufactured from cells containing hydrogen in the most abundant element on the earth. When used in fuel, produce no harmful emission. Hydrogen is a good one, but hard to produce it. Cracking the whip. What factor did not play a formation from the plant material? Formation of plant material is petroleum is not affected by sunlight. It's absence of oxygen, hydrogen, high pressure, high temperature. Let's do 124, which I'm going to continue. Which product is the greatest amount of barrel from barrel of petroleum, gasoline? During petroleum refining, catalyst, extreme cracking and reforming catalyst. We talked about that. The diagram below is a distillation column used in the petroleum industry. The position corresponds to cracker where large molecules are broken into the C is the cracker. Reformer is the B. D is the coker. D is position D is asphalt. Asphalt is coming out of the bottom A. Cracking is done at cracking is breaking up of larger molecules into smaller one. Compound with same chemical formula, that's isomers. B is isomers. These are isomers. Which are isomers? Same number of carbon atoms and oxygen. 1 and 3 is isomers. C is the correct answer. When you consider these 131, isomers are again 1 and 3. The second one has fewer carbons than the other two. Isomers are same formula, carbon number and hydrogen number, different arrangement. In a refinery, the compound of petroleum are separated by distillation, fractional distillation. C. Gasoline octane rating is the measure of the gasoline's resistance to causing knocking in an engine vehicle. You add ethanol, isooctane, and other MTB, etc. We talked about that. The burning characteristic can be improved by converting into isooctane. So they use reforming catalysts. They are platinum and palladium made out of. Number 135, oxygenators are blends with oxygen containing compounds. Which of the following oxygenator compound has been discontinued in the potential race? C is discontinued. We use ethanol. The formula of C3H, it is propane. General formula of alkane is CN2N plus 2P. What is the formula of octane? C8H18. 8 times 2 is 16 plus 2 is 18. What is the methane is CH4. The process by which solution is heated to its boiling point and vapors are condensed to collect known as distillation. Which of the following has the highest boiling point? High the carbon number. Octane has 8 carbons. It has the highest. Describe the octane rating and how it relates to combustion efficiency. It separates crude oil into fraction consistent in zero boiling point. The petroleum industry, what does refinery do? That's a separate crude oil into. Number 143. According to the graph, United States production of petroleum has steadily decreased since 1985. Petroleum I had to find out petroleum has consumption, production has decreased steadily after 85. That is correct. D. The second graph you can see it's 85. Graph showing. So these are just looking at the graph and completing the question. So last few questions are about biodiesel. They are easy questions. And cornstarch and climate change, assume that utility calculating energy from, okay. Let me see, I'm running out of time. Please go and watch the other video too, which I created previously. Okay, I'm going to stop the class today. You guys read the questions and get ready. Okay, I'm going to do chapter 6 next Monday. So then we have the test on Wednesday.